Welcome to all the learners, and in this lesson we'll start with the paper 2 from 2023. Question 1 and 3. Let's quickly get started. So in question 1, we know it's going to be statistics, so let's have a look. Truck drivers travel a certain distance and have rest before traveling further. A driver kept a record of the distance he traveled in kilometers on 8 trips and the amount of time he rested in minutes before he continued the journey. The information is given in the table below. So there we have it, the distance traveled in X, which represents X, and the amount of rest required in minutes, that will represent Y. So the first question states, determine the equation of least squares regression line for the data. So remember, that's referring to the straight line y is equal to a plus bx. And this section is completely calculator work. So if you're uncertain about anything, please go back on the previous lessons where we do this work in detail. So in general, you'll use your calculator and you'll put in the data, but first you'll say the mode stat, and then you'll use, in this case, the regression line, the REG. Put in your details, and then you go again and you go for stat, and you start recalling all the information. So specifically, we're focusing on the regression line data. Now, as soon as I put it in the calculator, we'll simply get the following values. You can have an option of A, B, or the R value, which is the coefficient. But for now, for the equation, we'll only use A and B. So A, we will get a value of negative 23,846. And for B, you should get 0,227. So my equation would simply be negative 23,85x, not with x there, plus the 0,2. Let me just correct that and just make it neater quickly, so it's just more readable and all that. Let's quickly give it a go. So it's negative 23,85, keep to 2 decimals, plus 0,23x. And that is your equation. The next thing we need to look for, so let's look at the question, is if a truck driver traveled 550 kilometers, predict the amount of time in minutes that he should rest before continuing his journey. Now, before I even try to answer this, first make sure that this 550 kilometers is within the data points that we do have. Meaning, if I look here, 550 will be between 400 and 600. So 550 does fit into the data we have. It's not outside of the boundaries. So if we were to compare it, any value lower than 170 or higher than 600, I will not be able to make an accurate calculation, because it's outside of the boundaries of the data we've got. But fortunately, 550 kilometers, we've got it. It will work. So for 1.2, we can literally just sub it in and say y is equal to negative 23,85 plus the 0,23 times 550. Calculate it and you'll get a value of 102,65 minutes. And that's the answer. Let's quickly look. The next question would be the correlation coefficient. So that's represented with R on your calculator. And then we need to interpret the answer. So just remember that. So let's quickly do that. So for 1.3, just go back to your calculator. Fortunately, we didn't erase any of the data. It's still captured in the background. So if you calculate R, you will get a value of 0,98. That is really high, which means if we need to interpret it, it is a strong positive correlation. So if it was negative 0.98, I would have said a strong negative correlation. If it was a value of 0.2, I would have said a poor positive correlation. So the nearer it is to 1, the more accurate this regression line equation is. And remember, it's only for data within our boundaries. Right, let's go on to the next part. At each stop, the truck driver spent money buying food and other refreshments. The amount spent in rands is given below. So that's the money he spent for the 8 stops. Calculate the mean amount of the money spent at each stop. So once again, you can either go and use the normal method that we are used to, and you can simply say that the mean would be the sum of all those points. That would be 1,200 over 8, and you would get 150. Alternatively, again, you can use the calculator, but this time you will opt for the VAR, the variance set of data. Right, and once again, if you're struggling, go back to the lessons where we do this in detail. Now I've got the mean. The next question they want is they say, calculate the standard deviation. Now definitely here, for 1 mark, use your calculator. Don't do a table. Quickly get your calculator. Just recall the data, and you will get your standard deviation is equal to 50,50. So this last part, they would ask us, at how many stops did the driver spend an amount that is less than 1 standard deviation below the mean? Okay, so let's quickly have a look. Just correct this as well. It's question 1.5. So 1.5.3. So 1 standard deviation below the mean. So I would first do this. The mean minus 1 of the standard deviations. So 150 minus the 50,50 is equal to 99 Rand 50 cents. So this is as good as the lower limit. Now, did he spend anywhere below 99 Rand and 50 cents? Let's look at the data. So this is above, 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 below, above, above, above. So there's only 1 stop where he spent below that limit. So make sure I answer them completely and say, therefore, 1 stop below 1 standard deviation less than the mean. And that's the answer. Let's go on. Question 2. At a certain school, the staff committee wanted to determine how many glasses of water the staff members drank during a school day. All teachers present on a specific day were interviewed. The information is shown below. So from 0 to 2, 5 staff members, 2 to 4, 15, 13, 5, 2, and it continues on. Complete the cumulative frequency column provided in the table. So remember, cumulative frequency refers to accumulating. We need to add it up. So if we look at the table, you start at 5. And I say 5 plus 15, and I get 20. 20 plus 13, and we get 33. 33 plus the 5, 38. 38 plus 2, and we get a total of 40. Now we go back. What questions do they have? How many staff members were interviewed? Okay, 40, because the cumulative frequency clearly indicates that 40 members were interviewed. So for the next one, so 2.2 would just be 40 staff members. Right, let's go on. For 2.3, go back. How many staff members drank fewer than 6 glasses of water? So if I look at the column, fewer than 6. So it means this group drank less than 6, this group, and this group. So we just need to add it up. So it would be 13 plus 5 plus 15. And we'll get 33 staff members. Right. Let's do the next bit. So, if we look at 2.4, they say the staff committee observed that K teachers were absent on the day of the interviews. It was found that half of these K teachers drank from 0 to 2 glasses of water, while the remainder of them were in the group of the 4 to 6 glasses of water. When K teachers are included in the data, the estimated mean is 4 glasses of water per staff member per day. How many teachers were absent on the day of the interviews? So let's just quickly go back now to this column. What they're actually referring to is that the K over 2, so this would not be 5, this would be plus 5 plus K over 2. And the other half would be at the 13. So it's plus K over 2. Right. So then they're referring to 4 classes per day as the estimated mean. How do we get the mean when we look at a column of grouped data? We start by getting first the midpoint in the first column. So from 0 to 2, we're working with the value of 1. 2 to 4, we're working with 3. Then of 5, then of 7, and then of 9. So to get the mean, I would have to say then 1 times the 5 plus K over 2 plus 3 times 15 plus 5 times 13 plus K over 2, and so on. Everything added up and divided by the grand total. So let's do that, because we do know the new mean must be equal to 4. So let's use the data we've got. So I would simply start and say that the mean is equal to the sum of the x values times the frequency over the total number. So we'll quickly start. So it would be 1 times 5 plus K over 2. And let's do it like that. Plus 3 times 15 plus 5 times 13 plus K over 2 plus 7 times 5 plus 9 times 2. Divide by the total number. Now originally there were 40 staff members. Now it's 40 plus K. And all this should then be equal to a value of 4, because they said the new estimated mean would be 4. And now we just need to solve for K. So let's start. So obviously I would first multiply out with the 40 plus K and try and simplify it like that. So we'll have 160 plus 4K is then equal. And if we try and simplify the top part, we'll have 5 plus K over 2 plus 45 plus 65 plus 5K over 2 plus 35 plus 18. Again, I'll try and bunch it together, multiply out with the 2, and at the end, you should end with 3K plus 168 is equal to 160 plus 4K. Let's quickly solve. I'll get 8 is equal to K. So therefore, 8 teachers were absent. And that is how we do the statistics for this paper. Let's quickly do the analytical question. Question 3. So let's quickly get started. So very important, in the figure we have the 3 coordinates, and they are on the triangle and the right angle, the 90 degrees indicated, and LN intersects the x-axis at K. Right, so everything is so far indicated on this drawing. So let's have a look at the questions. So the first question is calculate the length of SL, leaving your answer in surd form. Very important, then we don't use decimals. So SL, we just use distance formula. So we can say 3.1. So it's simply SL is equal, take the square root of XS minus XL squared plus YS minus YL squared. Substitute in. So it's 4 minus 4 squared plus 5 minus 1 squared. If you simplify, you'll get the square root of 80. And more importantly, make it 4 surd 5. Please do not make it a decimal, as they clearly stated it in simplest surd form. Right, now we look at the next question, the gradient of Sn. So once again, we have to get the gradient, which is straightforward. So let's have a look. So the m of Sn, we know how to get the gradient. It would simply be y2 minus y1 over x2 minus x1. Let's substitute. Careful for the signs. It's 5 minus 3 over 4 minus 2. Right. Quickly get an answer and you will get 8 over 6, which would be 4 over 3. And that's the answer. Let's look at the next question. Calculate the size of theta, the angle of inclination. Okay, we already got the gradient, so no worries. Let's quickly go for it. So for 3.3, I would just say that tan of theta is equal to 4 over 3. So theta would be on the calculator, shift tan of 4 over 3. So you get 53,13 degrees. Right. Now we look at the next one, the size of LNS. Now we need to go back to the drawing. So this we have as 53,13 degrees. And now we're looking for angle LNS. So LNS. So it's actually angle N. Angle N is nowhere near an inclination angle. So we have a few options. We have to look more at Euclidean geometry then. For example, I can see this theta is actually the same as this angle, because now I'm already starting to see there's a triangle here. I might be able to use it. The only problem is I need a second angle. So if I look at the drawing, maybe if I can get either this one or this one, it would work. But what do I know about this specific angle? This would be the inclination angle for Ln. So definitely I'll be able to get that. So let's first get the gradient of Ln, and then we can actually get its inclination angle. Let's quickly get started. So let's start with the question. So for 3.4. So I'll first try to get the angle K, that K1 that's on the outside of the triangle. But first things first, let's get the gradient of Ln. So again, 1 minus 3, careful for your signs, right? And negative 4 minus 2, and you get a gradient of negative 2. So if I want to get that angle, the inclination angle, I will simply say, go back to the drawing. Let's just quickly make that K1 to make my life just a bit easier. So I will say that the tan of K1 is equal to -2. So the reference angle, remember there's a negative, so we'll sort that out, means that K1 is equal to the shift tan of just 2. And you should get an answer then of, let's quickly have a look. So quickly go for the shift tan of 2, and we get 63,43 degrees. But remember, it's a negative quadrant, so we have to take 180 and subtract the angle. So therefore, K1 is actually equal to 180 degrees minus the 63,43, and we get an answer of 116,565 degrees. So I can now say, go back to the drawing. If I have this angle, this is exterior to this triangle. So I can say that angle N is equal to K1 minus the 53,13 degrees exterior angle of a triangle. And we can calculate it. 160 minus 160,565 degrees minus 53,13 degrees. And we will get that LNS is equal to 63,44 degrees. And that's the answer. Right, so remember, always consider your Euclidean geometry when doing these questions as well. Let's go on. Determine the equation of a line which passes through L and is parallel to Sn. Write your answer in the form y is equal to mx plus c. So parallel then means that that line will have the same gradient. So we already know that the m is equal to 4 over 3. So I can already say that y is equal to 4 over 3x plus c. So how will I get the c value? I substitute in a coordinate, and I do know it passes through L, which has the coordinate of 1, or -4 and 1. So let's just substitute that in. So it's 1 equals 4 over 3, -4, make it over 1 to solve, plus c. Let's solve for c, and you'll get 19 over 3. Therefore, you'll get an equation of y is equal to 4 over 3x plus 19 over 3. Next question. Calculate the area of triangle LSN. Right. Now we need another sketch real quick. Let's have a look. So we're looking for the complete area of this triangle. Fortunately, it is right angled. So I can stick to the area of a triangle is equal to a half base perpendicular height. So I need the length of LS and the length of LN. Now, fortunately, in the first question, we already got LS, and that was the 4 square root 5. So I just need LN as well. So we'll quickly calculate LN equal to square root. So it's -4 minus -2 squared plus 1 minus -3 squared. And you will get an answer of 2 square root 5. So substitute in a half, 4 square root 5 multiplied with 2 square root 5. And you'll end with 20 units squared. Please remember that to clearly indicate it every time. Right, so let's move on to the last part of the question. So let's go back. So we've got that. Now they say calculate the coordinates of point P, which is equidistant L, S, and N. And then the size of LPS. We'll get to that now. Very important. So there's a point P on this graph. That is the same distance from L and S and N. So if I were to consider N and S and get a coordinate that's the same distance from them, it would be the midpoint. But how do I know whether it's the same distance to L? Remember, we also learn from circles this year for the final exams, meaning we know that if that angle is 90 degrees, this is actually a circle, and that NS is the diameter. So I can do the following. L is equal to 90 degrees, meaning NS is the diameter of the circle of a circle going through LNS. Meaning I just need to get the midpoint of NS because the radius would be the same distance. So the midpoint or the coordinate of P would be the same as saying the x of n plus the x of s over 2. Then the y of n plus the y of s over 2. Substitute it in, negative 2 plus 4 over 2, and you get 5 minus 3 over 2. So that would imply that the coordinate of P would simply be 2 over 2 and 2 over 2. So the coordinate we'll get as 1 and 1. And that would be the easiest way to do it. Right, last question. Calculate the size of LPS. Let's go back. So let's quickly just draw in P here. So if that's P, L, P, S. But if this is the center of the circle, this angle will be double this angle. Why do I say that? Angle at the midpoint twice the angle at circumference. Think Euclidean. Right, so let's quickly have a look. So I will just quickly say that LPS would be equal to twice LNS. And now we quickly go and substitute it in, and you will get twice the 63,44 degrees, and you would get 126,88 degrees. But remember, we need to put the reasoning behind it. So I would say angle at center of circle is equal to angle at midpoint, at the circumference. So just remember your reasons and look out for this because this is a difficult question. And thank you so much. I'll see you in the next lesson.